In this video, we're going to have a look at some of the characteristics of an EQ, in particular the filter types that a lot of EQs come with. Now there's 3 or 4 different filter types that most EQs have. Of course it does vary from EQ to EQ. Some only have 1 type, some have only 2 or 3. This particular EQ that we're looking at, the Ableton EQ8, has 4 types, but we're going to have a look at all 4 of them. And in most cases, you'll have a choice between the different filter types. First of all, the very first default type is probably the most common. It's called parametric EQ or bell curve. Now, you can't really tell from looking at this picture. This is actually a bell curve pointing both ways. Some EQs will only show it going upwards, but it can also go down as well. That's because you can either boost or cut with this particular filter type. And you can either just usually drag a little circle like this up or down, but you also have the controls to the left here. The gain will either boost or cut. You can see we're limited to 15 dB, so this particular EQ will only boost or cut to 15 dB. And what we do is we choose the frequency that we want to boost or cut, and then this Q knob here decides how wide that boost or cut will be. So that's the bandwidth. That allows you to boost a number of bands either side of that frequency at the same time or cut them. I'll just trigger a drum kit while we're working through this. So one of the most common ways to use a parametric EQ is for finding particular frequencies, maybe that might be a problem that you want to cut out. One of the ways to go about doing this is to sweep through by boosting. And then when you've found what you want to cut, you just cut it like that. You might not always want to cut by that much, and you might want to only cut a very specific narrow band. So you just give it a higher Q. Now in some EQs, the Q works the other way around. So usually you can see on a visual representation here like this, but sometimes turning the Q up will actually make it go wider. Depends on the EQ type. So as well as the parametric or bell curve EQ, we have the low pass and high pass filters. Now what that means is they either pass through the high frequencies by cutting out the low frequencies. They can also be called a low cut filter. Most of the time you'll hear them referred to as high pass or low pass. So in this case, you can hear it's taken out all the lower frequencies, so anything under this frequency here is being cut out, and everything above it is being passed through. The same goes for the low pass. Everything above that frequency is being cut out and everything below is being passed through. Now you'll notice we've got this little, what's called a resonant peak here that happens when you turn the Q right up. But at lower settings, the Q really just sets the steepness of the slope. So at low settings, it's much more gradual and smooth cutoff. And at higher settings, it's much steeper and more extreme. Some EQs won't have a resonant peak here. This particular one does. And what that does is kind of accentuates that point where the cutoff frequency is, and it really just allows you to create these nice filter sweeps. So it really highlights the frequency as you sweep through it. So it removes these frequencies above the cutoff frequency much more steeply, and at the same time accentuates that cutoff frequency so you can hear it more clearly. But with some EQs where you might not have a resonant peak like this, what you might have instead is a choice of slopes. So you'll be able to control the steepness of the cutoff by choosing how many dB per octave it will be cut by. Usually it'll be like 12, 24 or 36 dB, some go up to 48. Really depends on the EQ. But while high pass and low pass filters are really nice for creating those kind of sweeps, they're probably more importantly useful for mixing sounds together. So for example, if you wanted to mix 2 kick drums together and they both have a lot of low frequency content, then you might want to take some of that low frequency content out of one of them and just have the other one more prominent in that region. But we're going to have a look at that in the next video, so I'm not going to talk about that any further here. But that's one situation where a high pass filter in particular could be really useful. And of course it works the other way around as well. If you wanted to remove some of the brightness or high frequency content, then you could use a low pass filter. Thirdly, the next type of filter we're going to look at is the shelving EQ. I suppose in a way you could say it's a bit like a cross between a parametric and a low or high pass filter. Maybe in the sense that you choose a cutoff frequency like you would with a low or high pass filter, but then you have the choice of either cutting or boosting below or above that cutoff frequency. So it's actually probably more like a home stereo EQ where you have a bass and treble control and it just more broadly boosts or cuts below a certain frequency or above a certain frequency. And again, the Q is for setting the steepness of the slope, so you can either have a more gradual boost or cut or a more extreme and sudden boost or cut. But you'll also notice with this particular EQ we get a resonant peak with higher Q settings, but we also get this little dip down here in the kind of neighbouring region. This can actually make a shelving EQ quite useful for mixing, say, a kick drum and a bass guitar, because you might want the kick to be more prominent in the sub-bass region, but you might want the bass guitar to inhabit more of these frequencies here. So this little dip could effectively be serving the purpose of making a bit of room for the bass guitar by cutting these frequencies a little bit here from the kick drum. Now, as I said, we're going to look at this more in the next video, but that's one of the benefits of shelving EQ. So just like with the low and high pass filter, you have two options, one for low cuts or boosts and one for high cuts or boosts. But you'll find it's not as extreme as a low or high pass filter because it only goes up or down by 15 dB. So if you want anything more extreme, go for a low pass or high pass filter. And the final filter type we're going to have a look at is the notch filter. Now, a lot of EQs might not have one of these, but it's particularly useful for notching out a specific band of frequencies, sometimes very narrow. So it could be useful for cutting out things like hum. So maybe if your recording has a bit of mains hum in it, then you can try notching out at around 60 Hz or 50 Hz, depending on where you live. And you can notch out a very narrow band by turning the Q right up, or you can make it quite wide so it takes out quite a large region by turning the Q right down. So you can probably see it's not really a lot different to taking a parametric or bell curve EQ and just turning a frequency down that way, but with a notch filter it's a much more extreme cut. In fact, I think it might be something like 48 dB, whereas the parametric EQ is 15 dB. So if you're just wanting to notch out a specific frequency, then that's what a notch filter can be useful for. So even if it's frequencies up here, you might have a really harsh frequency that's sticking out or clashing with something, then you can just remove that frequency band completely. And then of course you have an overall gain control. Sometimes if you go through and boost with a few different filters at the same time, then you might find the overall level gets quite high, so you might need to turn it down a bit here. Or likewise, if you're cutting a lot, then you can turn the gain up. So that's the basics of the different filter types on an EQ.